Okay, so my name is John Lane. I'm going to be teaching today for the Linux Basics. This is the Back to Basics that we're going to do today. Most of the content here is supported by the AFA Cyber Patriot program. The reason I do that is because I also teach Cyber Patriot for the Civil Air Patrol cadets. So I utilize a lot of the material in both instances, so I want to make sure that we're covering those bases. There's no legality for that. I just want to make sure that what we're talking about, I usually use it as an easy way to talk to young people for kids. So if I'm going too low, let me know. If I'm going too high, let me know, and I can kind of go in between as we work through this. So we'll start with Linux, if I can get my PowerPoint presentation. So Linux is a family of operating systems that Linus Torvalds began developing as a hobby in 1991. So the key about that is people don't understand it's actually Linux, right? Linux. And then Unix. It was actually built off the Unix operating system. So he took the Unix operating system and he did the, he built his own flavor with the kernel, and so he ended up creating a thing that we use today, which everybody calls Linux. But like I said, some of the people that are a little more hardcore, especially those who built like FreeBSD, probably call it Linux because that's what they're used to. It's open source with a few exceptions, but the actual kernels themselves are open source. They have a GPU or general purpose license. GPL. They have a general purpose license. Anybody can use it. Anybody can develop on it. Many programmers collaborate on it, right? And so many of the add-on programs that you can get with those are free. The packages and the things that you want to use. So it's I hear this a lot, that Linux is very user-friendly, but it's just very picky about who its friends are because it's kind of difficult to work through sometimes. So the Linux kernel, the kernel itself is the core component of the operating system, right? So it manages the system resources, the memory, the processor, input-output devices, and when a user does something in the shell, which we'll talk about the shell a little bit later, what happens is the kernel translates that and then it puts it into the bus and then integrates that. So you can see here we got the user who's inputting the commands, the shell, and then the kernel itself, which then is going to integrate with the CPU, the devices, and the memory that are inside your terminal. There's many different flavors of Linux, right? So there's Ubuntu, there's Mint, there's Kali. Those are all Debian based. So that's a certain type of kernel and a certain type of language that's being used within that operating system, right? So they're Debian based. Red Hat has a different base, that's the CentOS, is built on that framework. So you can also see up here where we have Red Hat and Fedora, Fedora is the open source free version of Red Hat, but it's frequently used as a test bed for the Red Hat program. So the difference, like I was saying before about them being open source, that you could use them, is they are open source, so you can use the software. But when you build something on it and you create something, then you can actually use that from a maintenance perspective, and you can say, hey, I built this feature, and if you want me to support it, now you can pay me for that. And that's kind of how those work. Like Red Hat. Enterprise Linux, you actually pay for a subscription service. So anything that you want to use it for, you can actually pay for, and they will keep it up to date and they will keep the patches and everything else, which you don't really have to. But if you want to work more in a community sourcing, you can actually integrate that with the rest of your sources, and you can work with the community to actually get those patches. Will they be perfect? Maybe, maybe not. Depends on what they are, how many people are supporting them. But you're not paying for those maintenance releases. So Ubuntu did the same thing when they did Canonical. So they actually created a subscription-based service that you can pay for and get your updates. The flavors are pretty much all similar, but they have very different interfaces and specialized commands. So some of the things that we looked at here, you were mentioning Mint earlier. There's Linux Mint right there. I like it from a networking perspective, right? It has a lot of features that I can use to do some types of networking. So when we talked about things like TCP dump, maybe using T-Shark and some of those things, they work very effectively on Linux Mint. Ubuntu is great for young people because it's a GUI base, so it's easy if you've never used Linux before. It's a great translation for you to go from Windows into Ubuntu. So it's very user-friendly that way. When you get into things that are a little more difficult, like what we use here is Kali. Kali is great. Why? Because it has all of the tools we use from a cyber protection and cyber threat hunting and all the other things that we can do with it. Kali's designed for that, right? Red Hat and Fedora are built on that CentOS and that Red Hat language, so they're just a little bit different. For example, instead of using .devs, we're going to use .rpm. So we'll get into some of that stuff a little bit later. Talk about some of those differences. So the differences between Linux and Windows, hey, look, Linux is often free or less expensive, right? You still can get a desktop environment, or you can choose to not have a desktop environment, right? You can actually go out and get Ubuntu and you can run it as a server and not even have a GUI. You can just use what you want it to. So it can be very light and fast and efficient. Or you can put all the bells and whistles and features on it and actually have this graphic user interface that you can interact with, which I'll show you later. But some tasks in Linux can only be run in the command line. So you have to kind of understand the command line and where things go. So once you understand what's going on within the command line and kind of know how that command tree works, you can actually do a lot of things. So it's very powerful and it's very granular. There's usually less malware on Linux because not a lot of people want to bomb themselves. So a lot of the people that are writing it, that's a joke. A lot of people that are writing code that is malware and things like that are going after the big companies like Windows and things like that, whereas Linux is more of a freeware supported. And certain hardware, unfortunately, can't work with Linux. So what happens a lot of times when we look at like a Windows operating system is people will pay for integration within the system. It gets tested and it gets added to the driver packs for Windows. So now they've paid for that integration to work. Some hardware, it doesn't work with Linux. So you would just have to look at a different operating system for that. So similarities to Windows, right? They can be both servers and workstations. I talked about that. So looking at Ubuntu, I can actually run that headless, right? I don't need a graphic interface. I can go in the command line, type whatever I want to do, and I can use it to provide services. I can do DHCP with it. I can do all kinds of things. I don't necessarily have to do it, but you can even do that with regular Ubuntu. You can run it as a server if you need to. FTP, SFTP, whatever you want, right? Linux servers come pre-installed with server applications, so if you want to use a desktop version, you're going to have to add that stuff. And we'll talk about how to do some of that as well, right? They can complete similar tasks. They're Linux programs that function just like Microsoft Office. It's called LibreOffice, right? Outlook, Thunderbird. You actually have specific applications that are built for these different Linux packages that are built for these different OSs, right? They're stable, like Red Hat and Canonical, I was saying, because you have subscription-based, so you can actually call. And I forgot to mention one earlier, but SUSE, that's another one that really has a good subscription service, but you got to pay for it. It's more in the European market, but you can get it if you need to. The vulnerabilities are kind of similar, right? So as we look at this from a cybersecurity perspective, I mean, if you leave 22 open, or you leave 21 open, or you leave 23 open, they're still attackable, right? So they still have some of the same vulnerabilities that Windows would have. It's just, it's Linux. So it's a little bit different in how you would apply that malware. All right. So we want to talk about the root account because there's two different types of accounts, right? A user account and a root account. The root account is really the Linux administrator account. It's like the built-in administrator for Windows. So Linux comes with that built-in root account. And the system can have multiple root accounts. You just have to make sure that the user's added to that, or you have to create a root account for it. And these users can switch between whether the actions are carried out as a user or root, which is one of the benefits of utilizing Linux is that I'm going to work within my stuff, or within my what I'm trying to work on, whether I'm working on an application or if I'm trying to build something, I'm going to work within that. And then I'm going to go, okay, well, I need root permissions or I need super user permissions, so I'm going to elevate my permissions to be able to do that one thing, and then I'm going to go back to doing what I'm doing before. So it actually makes it for a more secure implementation because guess what? If you don't have root permissions and you can't elevate it, you ain't getting nothing. Unless you want to do some other razzle-dazzle. But in this case, you're going to have that root account. So the root action requires a password regardless. So sometimes you can have that nice little built-in administrator account on older versions of Windows, and you don't even have to have a password. You can just do what you want to do, right? So that's definitely going to be a concern. And then root users are authorized to do many different type of tasks, but they have to authenticate. And again, you're going to see that when you go, hey, I want to do this thing like, I don't know, update Linux. When I want to do that, what's going to happen? It's going to say, put in your password. Oh, okay, no problem. Cool. So the file system, right? The file system is different from the Windows file system, and it does not specify really which drive the folder is on, but you're looking for forward slashes, which is very confusing for Windows folks because they're looking at backslashes. So as you're typing everything out, you got C:\\\/ this. In Linux, you're going to have / root, or you're going to have / file, / etc, / whatever you're trying to get to. But you do have some help though, right? So you look here at the Windows one where I said like C:\\/ documents. In Linux, it's going to be / home / Linux basics and then find the file. The key here is look at this. In Windows, I can type documents, I can move on. But in Linux, if it's context sensitive, it means you got to have, if it's uppercase, you got to write it with uppercase. If it's not uppercase, then you got to leave it as lowercase. Otherwise, you can't even find it. So it's very context sensitive, and it does matter if you put those slashes in the wrong way. It's going to be like, I don't know what you're talking about. All right, so the important folders that we talk about is like the home folder, which is like for your users' documents, media files, and users can only access their own files unless they elevate their permissions, which we talked about before, right? If you go in there and you go, all right, I want to access this person's file, it's going to say you're going to have to do a elevation of privileges, which is sudo, and we'll talk to that later. Or the boot drive, which is kind of like the C drive, actually going to contain all the startup files and the kernel files. Please do not modify that file unless you plan on reinstalling your operating system. Running joke across everybody is like, I'm going to enact my RMTech RF star, right? Go ahead, reload it later. It's fun. All right, adding and removing software. If I'm going too fast, just let me know, because we got a lot to cover and not a lot of time. All right, so Linux software is bundled into packages. So I talked about this from a package manager standpoint, right? So if we look at Ubuntu, we're going to look at .debian packages because it's Debian flavored. If we're looking at Red Hat, we're going to look at RPMs, or Red Hat Package Manager. So you'll see .rpm. So these are managed by package managers. In Ubuntu, that package manager is called the Ubuntu Software Center. And we're going to talk about more of the Ubuntu stuff because that's kind of where we're going to stay today when we do our install. To access the Ubuntu Software Center, you can either get the shopping bag or the Ubuntu menu. On the menu bar, it's kind of like using your Mac, so it's a little bit easier if you already understand Apple. You're kind of looking at the same thing anyway. So the Linux file system is actually, the files are stored in directories, right? Which is the same kind of as folders in Windows. The file system tree is based on a trunk. That's what that slash is for that root, right? So you have the root directory and then you have your trunk of that. And each one of the branches of the tree are actually like directories. So if you look here, as we look at how this is built, so here we have our root, and then underneath it, we're going to have these different branches, and then underneath that, we're going to have the leaves, which is actually going to be the files themselves. So if we're thinking about it as a tree, which kind of looks like a tree, you can kind of follow this process to see where everything is at and to see how to get from one point to another. So you're looking at things like Etsy, or you're looking at things like Home, like we mentioned before, that had the user account, and then the user's files, like their documents and media files and stuff like that. So this is what really turns a lot of people off when they start looking at Linux, is because they have to do a lot of stuff in the command line. Now, it's not something to be scared about because the command line has pros and cons, right? It provides the user with more control. Like I said before, it's granular. So you can actually get in and do things all the way to the endpoint that you want to get to. But unlike the GUI, those are like pre-programmed certain tasks where you can actually go in and just like, oh, I'm just going to click this and it's going to run. Well, in Linux, if you're in the command line, you actually got to run it. Otherwise, it's not going to work. So some ways, or only the way to save it is to be in the command line. Because if you're not in the command line, there's some things that you can't even do. Like we talked about that before. Like if it's a script, if you want to run a script, you're not going to run that from the GUI. You're going to have to be in the command line. You're going to have to navigate through the file tree to get to where the script is and then run it from there. And you can either do that from two different ways, and we'll talk about that. Either it's going to be a relative path or an absolute path. So there's both ways that we can get after that, right? So the command line can be very scary. It uses bash. You'll see that on some people's Teslas. I saw that one in the parking lot. It's /bin/bash, which is really just the born again shell. They were trying to be funny, which is cool. I like nerd jokes. But the cons are it's really not as user-friendly, so it turns some people off, right? And it is harder to multitask. If you're used to having like a bunch of windows open, you got to kind of tab through the windows to get to where you want. And if you forget where you're at, then you run a command. It doesn't really work, so you have to kind of navigate back to where you want to be. So it can be confusing because every one of those terminals, unless you do something different for each terminal window, is going to look identical. So it can be confusing. All right, accessing the command line, that's super easy. I like to use my shortcut, Control-Alt-T. That allows me to get to it and it opens a terminal. But you can do it from the menu itself, because all you got to do, and we're talking Ubuntu specific, is to go up to the top, click your little Ubuntu wheel, and it'll drop down to the command line, and you can click the command line and it'll open that command line for you. And so it'll open a terminal, because that's what that is you're actually using a terminal to do that. So you can do things like SSH, whatever you want to do from there, but it's your command line. So easy way for me, Control-Alt-T, and that's what I'm going to do when I walk through it. So using the terminal. So when you're typing commands in the terminal, you have to pay attention to capitalization spaces like I mentioned before, because it's context sensitive. So if you're looking for your documents folder, it's a capital D. Well, then you're going to have to type a capital D tab, because you do have context sensitive help for some ways, because you can like tab stuff out. But if you use the wrong capitalization or spacing or numerical value, it won't find it. So you're going to have to actually go through and look at stuff, or maybe list the files in that directory, which we'll talk about how to do that in a few minutes, so that you can actually see what's in there, right? And hitting enter will execute your command, and Control D closes any commands that you have running or exit the terminal. You can also use Control C to break commands. So there's some other functionality that you can learn, but you really, in order to be very effective within Ubuntu, two things I recommend is the Linux Pocket Guide. So I think if you talk to Rob, maybe he might have some floating around. That would be good for you guys to look into. Or if you want to hit these links, help.ubuntu.com or Ryan's tutorials or man pages or Ubuntu manual, you can actually see what kind of commands that you want to use, and it'll help you. And as always, Google's your friend, right? So if you want to, hey, how do I do this? Google it, and it'll tell you. Just do this. So let's talk about the command syntax, right? So if you're writing the commands in the terminal, you're going to look at three things. Well, four in this case, because there's an operator in there. But you're looking at the command, any type of switch or option that you want to use. In this case, there's an operator in here, which we'll talk about, which makes it push to the output to this location, and that's the location, the file name and the location. So what we have here is the file name, and this is the location. And then this is the operator telling the switch to take this information and push it into that file, so that if I write that, it'll actually create hello2.txt, and it'll take whatever it is that I'm running, whatever I'm catting, and put it in there. So the command tells the computer what you want it to do. The option customizes the output of the command, and in this case it's going to number it, so each line of text. So when you do that, you can run it, and you can see on the left hand side within that text file the number of the lines that you actually wrote. So if you wrote a few things, you're typing a few stuff up, it's going to go into that file, and you'll see numbers on the left hand side where you can actually look at those. Options are not required for all commands, right? They're specific for whatever you want to use it for. And then the operator directs the output of the command. Like I said, it's pushing that information of what you're trying to do into that file, hello2.txt. They can get complex, that's for sure. So let's look at some of the navigation commands. This is important because sometimes you forget where you're at when you're in the actual the command line and when you're in the terminal. So PWD does not mean password. It means present working directory. If you want to change the password, you actually have to type password. But in this case, it's present working directory. So ls, I talked about that to list the files that are in that directory. So if you get somewhere and you type in something and you tab it and it's not coming out, just run a quick ls and see what's in that directory. Because then what it's going to do, it's going to show you all the files that are actually in that directory. And then you can say, oh, that's what I meant. I forgot to capitalize it. Or I forgot there was a number in the front of it. Whatever that might be. Tip for you guys when you're creating files and saving them, do not use spaces in your files. That is horrible in Linux because you have to account for that space. So if you're going to actually do something, you're going to have to either spike it on both sides so that you can use it, or you got to change that file name so that you can have just a continuous file name. I prefer using like underscores if I want to separate stuff out so that I can actually have those underscores to limit what's in that file name. But make sure you don't use spaces because it's going to hurt you later. So CD works the same as it does in Windows, change directory. And then these are the two things that we wanted to talk about, was like an absolute path and a relative path, right? So the absolute path starts from the root directory. So I tell all my cadets when we're looking at this stuff, hey, look, CD/home. So you're starting in that root directory. You're looking for that /. But a relative path, you can do that with a dot, right? You can do that with one dot. You can do that with two dots. So you can determine where you're going to be. Also, if you're confused and you're looking for something in a relative path, you can look for the tilde, which is actually the little swoosh looking thing at the top of your keyboard. And if you see that in front of it, that could be a relative path as well. All right. So who's the man? I don't know, we talk about this sometimes. Who's the man? So man is short for manual, and it displays the manual for a command. So if you're looking for anything within your Linux operating system, it's great that they already put all that stuff in there for you. So all you got to do is type man to look for it. Man, whatever command you're looking for, and there should be an excerpt or a blurb on there that tells you what it is. Since they're flat files, they're not very big, so if you look at it like Ubuntu, you can have all the stuff that you need to do to work that operating system right there. And you don't have to go to Google, or you don't have to go to Ubuntu's pages and look for the commands, which is really great if you're working in a disconnected environment. Because if you're in a disconnected environment, you may not have access to the internet, you may not have access to Google, you may not have access to phone a friend, right? So Man will help you find the stuff that's in there. If you want to navigate through the manual, just use the arrow keys. Up, down will get you through there, and those page up and page down will get you pages up and pages down. And if you want to get out, just type Q and you'll exit, right? Sometimes if you want to look for a command and you're confused about what it does, you can do a tac help or a tac H, and it will actually give you the information for that and kind of help you out. So Linux is very user-friendly, but again, it's picky about who its friends are. So when you type ls list and then tac help, press enter, and it displays all the help commands for the ls. So it's kind of like in Windows where you go in the terminal and you don't know what you're typing and you type something and it gives you a list, a whole bunch of stuff. At least this way it kind of tells you what you're looking for, which is helpful. All right, so file contents and output redirection. CATS for file stands for concatenate. It concatenates files and prints the standard output. Well, that's good because it'll help me take a bunch of stuff and put it into one file. That way I don't have to go looking for it. When I'm doing coding, I actually want to break those up into small modular flat files because I'm going to use those from a modularity standpoint. But if I want to read a document, I don't want to flip through like 8 pages to try to find what I'm looking for, so I can cat them all together. File determines the type of a file, so if you're looking for a file, you can actually do that. Or echo, you can display a line of text from the command line. And even you can do this, you can write the command, and then you can output that. That's that operator we talked about before, and it'll take the standard output of the command and redirect that to a file for later. Super helpful if you're like trying to do, I don't know, T#, or if you're trying to do like TCP dumps, or if you're looking for any kind of things that you want to look at, super helpful to dump that output and then go back later and look through it. All right, one of the most important commands that you have, sudo, stands for super user do. This is elevating your privileges so that it allows an authorized user, a person who has root permissions, right, to temporarily elevate their permissions using their own password instead of having to know the password. Because like if I don't know the password, I might have a problem if I don't have the root account. But if I'm in the user group and I have elevated permissions, then I actually can use my own password to then run those commands, which is nice and helpful from an accountability standpoint because now I know who did what and I can actually trace that back. So you have to do it if you're going to do administrative commands, right? So if I'm going to do add a user, if I'm going to make updates, if I'm going to do anything within the command line that requires those elevated permissions, I will have to do a sudo command to do it, or you can navigate to the root if you want to, because some people like to do that. So you could do the sudo su, which then will be your super user for that session, or you can just do root and then now you're using the root command. So I would advise from a cybersecurity standpoint to not do that, to actually use your privileges to do whatever it is that you're trying to do. So that brings me to the installer portion, right? Ubuntu is super easy to install. Now for some of you, unfortunately I didn't have thumb drives to be able to hand out to everybody, and I don't know what the Wi-Fi is going to be like here to be able to take all this information. So if you guys all try to download the operating system at the same time, it's going to be problematic. But I can promise you this, you can go get the operating system anywhere, anytime. It's free. You can just go download it and you can run it. So for this exercise, you go to this location right here to https://ubuntu.com, download, desktop, or like I said, you can copy it from the USB. So 2404, I think .1 is the latest version as when I made this. So that was a couple of weeks ago, I think it was. So I think that's there now, but we could always look it up and check. For this demonstration, what we did is we installed it on the VMware Workstation Player, which also is free. So you can get that from VMware, so you can download that. One of the things I know Mark likes to talk about is that you can get this experience for free. It doesn't cost you anything, just the initiative, right? It costs you a little bit of hard work to go out and get some of these tools, put them together, and you can play in your own time. You can play with these tools at your own house, on your own machine, and you can really learn a lot, not only just by breaking stuff, but by installing stuff and working through things. So this gives you an opportunity to create this lab environment of your own just by using VMware Workstation Player. Again, it's free, doesn't cost you anything. As long as your machine has resources on it, and as long as your machine has the ability to run virtualization, because some operating systems don't like it when you do multiple virtualization, so you have to kind of work at that. Especially if you're going to do like nested virtualization, that's a whole nother thing. then you just download VMware Workstation Player. So I'm going to go through these real quickly, and then I'm going to do it, and then you guys can see it. Yes, sure.
So is this setting up Ubuntu on like a dual boot on Windows?
Nope. We're going to install it as a virtual machine. So what that means, it's actually going to be virtualized on top of your operating system. So you'll see as I'm building it out, it's actually just on the computer itself. Yep, good question. So like I said, we're going to install it on VMware Workstation Player. As you can see the settings, I actually have the ISO stored on my D drive. So I'm going to pull it from the D drive. I'm going to browse to that D drive so that I can actually bring it up. And then from there, you can see I cheated with Mark's because I was using Mark's Ubuntu Splunk from the other day. So I was able to do that from that test when we did the Splunks. So you can install it from there. The next thing that you'll do is create the virtual machine. And with the Ubuntu installer, it actually gives you the ability to add some unique configuration tasks on the front end, so you don't actually have to do that on the back end. But you can do it either way. You can either use the automated installer, which is kind of help, the easy installer wizard, or you can do it manually. So right here, I just put the Linux basics in it for the username, and then I put a password. I always use the same password. Don't tell everybody, but I use the same password. You can use whatever password you want, because I'm not going to tell you my password, but use the same password and name the virtual machine. So in this case, it was just Ubuntu 64, and then it just pushed it out to my documents folder. All right, so then go into create the virtual machine, just using the basic settings, the maximum disk size for this. So make sure you have at least 20 gig of space. I prefer to do a single file with this instead of multiple files. If you get a bigger system that you want to do within your operating system, go ahead and break that down into multiple files instead of just one, right? But if you want to move it for ease of movement, one file is much helpful, because then you can actually move that where you want it to go and then re-upload it later if you need to. On this other one here, here's the settings. So for this model, what we did here is I had 2 CPU cores, I had 4 gig of RAM and a 20 gig hard drive, and I'm using a NATed network adapter. So you can actually customize these as much as you want to, however you want to customize it, as long as your machine has the resources. So if you've got a big beefy gaming computer, you can go crazy with what you want to build on these things, and you can build multiples. Now, caveat, if you're using VMware Workstation Player, which is what I'm using here, you can only build one at a time, right? You turn one on, you run it, you do what you want to do, and then you shut it back off again. If you want to go in here and you want to put multiples together, VirtualBox from Oracle actually works better for that, or VM Workstation Pro. So if you have VM Workstation Pro, you can do it that way as well. So this is just showing you basic settings as it comes in. It says welcome to Ubuntu. I chose English. Accessibility. I showed you just clicking the basic settings as I'm moving through this. This isn't really the easy stuff, is just simple here. It's not a problem. Selecting the keyboard layout and connecting to the internet to use the wired connection, because I'm going to do that here shortly. And then go ahead and do the install for Ubuntu. And I did the interactive one because I had set those settings already previously. And then I went to the default selection. We'll show all these again, so it's not a problem. Install the proprietary software. So the problem that I run to here is that in this environment using a low bandwidth, I don't want to go through all these things, because if I download all the support and everything else, it's going to take up some of the bandwidth as it's trying to download that, along with the updates. So that's something that you may not want to do if you're just doing a quick install for something to test with. But if you're at home on your Wi-Fi, knock it out. Do what you got to do. In this case, I was telling it I wanted to erase and install Ubuntu. When I pull this up in a few minutes, I'm going to show you some of the other options that you have that you can kind of go through. But for this exercise, just go ahead and use all 20 gig, because, you're just doing a quick test. Creating the account. Here's all the information for the account, and this is kind of important right here. Require my password in order to be able to log on. Otherwise, it's just going to boot right into it, and you don't really want that. You want to protect your system. The bottom one says use Active Directory. The Linux systems can be joined to an Active Directory environment, right? So if we're looking at Red Hat, we can do a Realm join, or if we're looking at Ubuntu, we can also integrate that directly with Active Directory. So it's not that Windows and Linux can't work together. They absolutely can. In fact, they do that in many large enterprises, because we use Linux for a lot of different things, especially for smaller tasks that we might want to do multiple nodes, or if we want to do some different kind of things that are not directly for Windows or in that environment. So it quick to review the choices, and then it builds it. So we're going to stop right there so that I can actually show you kind of what I did to go ahead and build it, and I'll just build a new one. Kind of nervous about this because anytime you do anything live, it works, but sure. Let's go ahead and close that because they always want to try to sell you something. All right, so we're going to do the same thing that we recently just did in that little demo, quick demo. I'm actually going to create a new machine. So I'm going to do a new one, new virtual machine. I actually have the ISO. So if I wanted to browse, I have a couple of ISOs in here, but I just picked the latest one that we wanted to install. So I'm going to go ahead and cancel that because it's already in there, the 24.401, as you saw in the demonstration. Now, again, you could do a couple of things here because VMware or any type of virtualization option gives you the ability to modify and customize, right? So I can actually say, you know what, I'm just going to customize it later, and I can do it myself from an installer disk. Yeah, I could, but I already have the ISO, so I'm just going to go ahead and use the ISO that I have now. Again, if you go to the Ubuntu website, you can download the ISO. If you get with one of us, we may be nice enough to share it with a thumb drive in case you want it. If not, like I said, when you get home, you can go ahead and download that. So here, we're going to put whatever we wanted to in there before. In this case, I was using Linux Basics, right? And underscore basics. And then the username is going to be all one word, Linux Basics. And then the password, I'm going to put my super secret password in here because I don't want to tell you guys what it is. Otherwise, I got to change every password for every training system I have. All right, so it took that. So now the virtual machine name, I don't care what it's called. You can call it whatever you want to. We'll call it Linux Basics. And then the location that it's going to install, it's going to put it in my documents folder because that's where VMware likes to put it. You can always move that to a D drive if you need to. If you need more space, you can put it on somewhere else. It's not a good idea. I am not a pinnacle of cyber hygiene with this laptop right now to put it on your C drive because if you fill up your C drive or you put something in there and corrupts it, now you got a problem. If you put it on your D drive, you can always fix that later. But this is what we wanted to look at. So I'm going to go ahead and do the installation. Remember, for the other one, I had 20 gig, but what did I tell it to do? Does anybody remember? Made a single file just because it's easier. You can do it multiple files. The larger the machine, the more you're going to want to do that because you're going to want to have to break those up. You don't want to have like a 50, 60, 80 gig that you got to move around. It's easier to use smaller VMDKs. So it's just going to tell me everything that I want in here. So in this case, I'm going to go in here, I'm going to look at customizing my hardware. So based on the installer for the ISO, it writes a few things in there and it says, hey, I think that this will work best for you. And that's what it's going to put in there. They're changeable, just like we talked about. I know that my system has 16 gig of RAM, which is right here. It says maximum recommended. If I use that, it's probably going to crash my system. So I don't want to do that. 8 would probably be good if I really wanted to use a few things, but it's Linux, so I don't know that I need that many resources unless I'm trying to do something very specific. Processor-wise, I have quite a few, so I could use a couple of them if I wanted to. In this case, I'm going to use at least 2 to make it work. I have run Linux machines in AWS, just 1 and 1. 1 gig of RAM and 1 CPU. They're very small, they're very light, and they're very effective. I would not recommend running a graphic like an Ubuntu desktop that way with a 1 and 1. It is very slow. You won't like that. So this one has a CD on it. I'm using a NAT adapter, and pretty much everything I need in here is about what I need. So I can go ahead and close that out, and I can go ahead and finish my installation. And it'll power that virtual machine on when I'm done. Now this is going to take a few minutes, so we can talk about a few other things. So once we get this installer going, we can build out a few other things in Linux. Remember, everything is going to be based on that command line, so I'm just going to wait for it to finish opening here and close a few other things that are bothering me. You can see the installer is getting ready to run, so it's actually starting to pull some of that stuff in from the ISO, so it'll start building these things out. It really only takes about a good 20 minutes unless it depends on what you're running, right? Slower machines are going to take a little bit longer, and sometimes you run into an issue where it might take you 30 minutes to an hour to run one of these things. But it shouldn't take me that long here because I kind of tested this before. This isn't my first installation. And I'm hoping that through that we can get to some of the other things that we had talked about, which is going through the configuration modules. So we did this part, right? We configured it. We did this part. We kind of created those things, the virtual machines, the password, everything else we wanted to do. We changed the size of the the hard drive, or not size, but whether it's being distributed in a single file or multiple files. And we made sure that all of the settings that we wanted to set were actually set the way that we wanted them to be set. So now it's going to go into the installation part. So this is back to the live version. So here it's trying to load some stuff. It's trying to do some things. My computer's probably not going to be happy because it's probably going to need some updates and only got 1 bar. So we can go back through and we can look at some of the things that it's going to try to tell me, which is choose your language, choose your accessibility, select a keyboard layout, connect to the internet. So some of the things that we're going to want it to do. And again, it's still trying to wake up, so that's going to take a few minutes. Now I do have the ability to run my own system, so we can actually do that. And we talked about how you would like to install it. So we're going to run through these things again before we actually get there. So it shouldn't take this long. Always great when you do it live. In the end, once we get our system loaded, which I can bring up a system and we can walk through it, because I think we're running short on time. So let me close this. I'll just pause it for now. Yep, I'm okay with that because I can always reinstall it later. VMware. And let me get to the other meat that I want to show you guys before you leave. And this is why we do multiples, because we don't have 20 minutes. All right, so this will be your post installation, which will look like this when it's done. That's your post installation. As you can see, it says Linux Basics right there. So I'm going to click on it, put in my super secret password. And now, if some of you guys were looking at this, remember what we talked about earlier, right? Control-Alt-T will bring up my terminal, and there it is. Or you could go to the Ubuntu and actually pull it up here in the top. Oh, not there. Come on, I gotta make it big. There we go. And I'm gonna look for my terminal. It's actually hiding down here. So look for the Ubuntu symbol and then go to the terminal, and it does the same thing. That's why I like Control-Alt-T. So now I'm gonna minimize this back down. I know I'm like bouncing around through stuff, but I wanna show you things. So what we wanna do is we wanna try some of the things that we just talked about, right? Like listing file systems or changing directory. So let's look at that. If I want to list file systems, hopefully you guys can see all these things. Can you guys see that? Perfect. LS. I did a list of that directory, so I can see the desktop, the documents, the downloads. Well, do you guys remember what we were talking about before? I don't know where I'm at. So if I hit present working directory or PWD, it tells me I'm in my home directory for my user account. My user account is Linux Basics. So that's where I'm sitting. And these are the files and folders that are in there if we wanted to look at those. So if I wanted to go to, I don't know, documents, I would type in CD, change directory. Remember, Linux is context sensitive, so I'm going to type D, capital D, and then I hit tab, nothing happens. Well, that's because I've got desktop, documents, and downloads. So if I do an E, that's desktop. But if I didn't want that, I said, maybe not. I hit O. Oh, it still doesn't work. Why? Because there's 2 choices. So if I do documents, then it puts me in the documents, and we'll do an LS again, and we'll actually list that file out. Okay, what's in my documents? Well, there's 2 text files in there. Well, that's cool. There's 2 text files in there. I wonder what they say. There's a way to do that. You can just cat the file. Oh, wait, I can't cat hello. Why is that? Because, again, I have to have the full information of it because there's more than one file that has the word name hello. So when I do that, that's what's in that file, hello world. Ooh, wow, exciting. It's right there. All right, so here's a couple of things that we talked about, right? If I want to do this and I want to go into the root file, I can look for the Etsy directory, but we did this as an example with documents. So it's a little bit different from the presentation, but it's the same effect, right? But if we wanted to look into the Etsy file, I wouldn't have to worry about anything other than just do ls/etc, enter, and I could actually look into the Etsy file to see what's in there. So these are all the things that are running inside there, like the shadow file. Might want to look at that if you want to look for some passwords. I don't know, you could find a few things in here. So as we're looking through those, we talked about Etsy and we saw what's in the Etsy file. But you know what? I've been typing in here and everything's busy and I can't see anything. So if I type clear, it'll clear it back out and now I don't have all that stuff. So I can keep typing things that I want to do, and then when I want to clear it out, I'm just going to type clear and get rid of it. All right, keeping it going. There we go. All right, so creating a file. If I want to create a file, then I can use the word touch, or I can actually do a nano, or I can do a VI. Whatever I want to do to create that file, I can actually create it myself. Touch works, but then I got to do some manipulation. Nano works, and we'll talk about that, or VI works, but then you actually can configure the thing. So let me see, if I want to create a new one, remember we looked in there as hello 1, hello 2. How about we do a VI, and we'll type hello3.txt. And there's my file. So now I can type anything I want in there. You know, it's my file. I can type whatever I want. Hello world 3. Oh, what's going on? This thing's not working. There's something wrong here. Okay, so I'm in VI, so in order to be able to work it, I either got to type I or insert. Those are my two options. Once I type insert, now it'll let me type hello. Oh, still having trouble. Hello. There we go. Oh, something's not working. Escape, colon, quit. Let's try that again. Oh, that didn't work either. Escape, colon, quit, force it. I'm out. All right, let's try again. Hello, insert, hello.txt, or hello world. We could do that too, I guess. That'll work. That'll work. So now I'm going to escape out of that. Colon, I'm going to write it, and I'm going to quit. That's what that is. W, write to write it, and Q to quit it. And then hit enter. Now if I cat that file, cat hello3, .txt, I get all the gobbledygook that I just typed in there. Okay? So VI is a way that you can use that virtual editing to be able to edit that file to create the stuff that you want inside that text. Like if you're going to create a bash script, or if you're going to create a text file like we just did. But it uses certain commands to be able to navigate it. So you could man that if you wanted to do man VI, and it would give you the manual, because remember we talked about manuals earlier on when we started. So now I can see in Vim all the things that I want to look at, or VI improved. I can actually look in here and see what kind of commands I can use. Now there's a lot there, so I could probably hit a page down, or I could just use my arrow to get through it. And as I find whatever command that I want to use to modify it with, okay, that's what I wanted, cool. So hit Q, and now I'm out of the man files. So these are some of the things that we talked about when we first started, so I want to make sure you guys actually can see what they do. So in this case, we created a file. I didn't use the touch command, but it basically will do the same thing if I want to do that. And so again, this is where I was using nano. You got to see to use the command write quit. So that wrote the file. Before, when I was having issues, I just did a quit and an exclamation point, which forced it to quit without saving anything. All right, so the next one is to use nano. So for some folks, it's just easier to use because it may not be as good, but if you're a diehard Linux fan, you get kind of dirty when you start using nano, because some people complain about it. But hey, look, I want to use whatever works, right? So nano, for this demonstration, we'll use nano the file, and we'll create a new one. This one will be hello4, hello4.txt. And so you see a different kind of text editor opens up, and we have a few things that we can do in here. So unlike VI, where I have to insert whatever I want to insert, I can just start typing away. Oh man, I typed all that stuff. Okay, let me backspace and get rid of it, because remember, in VI you have to use different commands to start getting rid of stuff like Control X and things like that. But here I'm going to type a few things. Okay, that's great, nice. Now I want to save it. Control S, Control X. That's all I had to do. I didn't have to do like escape, colon, write, quit, or bang, or whatever. It is faster, but it just depends on how good you are, right? So if you're very familiar with Vim, or you're very familiar with VI, you'll be very fast. If you're very familiar with nano, you'll be very fast. So it really doesn't matter. So if I cat that file again, hello4, that's all the gobbledygook that I typed. Cool. So moving on, we talked about nano, updating the OS. I can't do that right now because if I'm on my phone and I try to do the update, it's going to take forever, so we wouldn't get any more information out of it, and I want to talk about a few other things. We still good on time?
I think so.
All right, cool. So if you want to do an update, you're going to have to do an apt-get update or an apt update to be able to update your Ubuntu. The key here though is that if you're doing an update, you're going to have to use a special term. You're going to have to do your sudo, because otherwise you're not going to be able to get some of those because it's going to be locked. Again, I don't want to run this right now because it's going to do all of the updates, and that's going to be a problem because it's going to lock the machine up for me to be able to do other things for you guys. So if you want to update the OS, use that term. And when you're installing software, it is always, always, always a recommended best practice. Apt-get update, apt-get upgrade, so that you make sure that you get the latest packages and the latest dependencies and libraries before you install that software. So get familiar with that. Sudo apt update, sudo apt upgrade, and I hate to say this, but I always cheat and use a TAC-Y so I don't have to actually approve them later. That may not be the best practice because you're going to be updating something that you probably need to look at. So think through that one before you do it. All right, sudo command, we talked about that. So that goes with that apt-get update, because in order to be able to do that update, you have to have elevated privileges. We talked about how to do a sudo, super user do. And when you do that sudo command, you're going to need to put in your password. So I can show you how that works. If I wanted to do something, I'm just going to go, let's see, rm hello4. Nope, that did not work like I wanted it to. Okay, but in this case, I'll just do sudo, and then I'll say rm hello2. How about that? Because I don't think let's do hello3, because I know I created that one. All right, it's going to say, hey, you need the password. So, okay, cool. Put the password in, and now it's gone. So if I ls that, those are gone. Sweet. Yeah, the problem is it's deleted. You ain't getting that one back. So you can try again, create it. So after it finishes install the update, you can do an update now. I'm not going to update this because then it would just take forever right now. Upgrade, like I said, I do the sudo apt-get upgrade. So this is where we want to try some other commands. We showed you the present working directory. I showed you how to do a cat. I showed you how to do a man. I didn't do an echo, but I can, if that, you know. Echo hello world. I hope I spelled this correctly, otherwise it's going to fail. Oh, there it goes. Okay, cool. Hello world, and then just reproduce that. So you're just actually taking that syntax and pushing that back so that you can write it. So you can say echo. Very helpful if you need to present a command within a script that you want to do, so that you can actually present that text or whatever it is variable to it. So echo is in there. So those are some of the other ones. The last one I want to keep because it's breaking into what I want to talk to you about. What I want to talk to you about on this next one is permissions. So this is where people are going to start to get confused and have issues. So if I do an ls tac l, it's going to list the permissions for those two texts that I have in there. But there are other things that are hidden in there that you can't see. So I'm going to use an ls la to list all, and it's going to show you a couple other things in there, which is the back directories that we talked about before. So those were in there when we were talking about relative path and absolute path. So there's relative path for the directory that we can go back on. In this case, when we look at those two files, we see the permissions. I see a couple of R's, a couple of RW's, a couple of DR, directory write, directory execute, a couple of things in there. Why is that important? Because of this. So permissions. Each file and directory has three types of permission groups, right? The owner group, and that's the owner permissions apply to the owner of the file. The group permissions apply only to the group has been assigned to the file, and then the all users permission, which then allows anybody who has access to be able to access it. So you can see here in a much, there's a lot more files here, but they're assigned to the root. So when I look here, those files are assigned to Linux Basics because I created them. That's why. If I was going to look at something else, I don't know, ls tac la /etc. Let's not do la. Let's just do /etc. You would see a lot of root permissions in there because the root account is what was used to create those files. That's why you're going to see them that way. But if you look in mine, ls -l, you would see that it's only Linux Basics because it's me, the user that created those files. So as I'm going through those permissions, I want to be able to change those permissions, then I have to be able to identify how I'm going to change those permissions, right? So R stands for read, W stands for write, and X stands for execute, right? So if I have a permission in here, which I'm going to have to look and see what I've got. So I've got a couple read-write permissions on hello2. Sweet, this will give me the opportunity to do this. So if I look at this, I want to change those permissions, right? So to remove the read-write permission, I'm going to invoke the command chmod or change modify, A, I'm going to add, but I'm going to actually do a minus because I'm actually going to take that away. So if I look at Linux Basics 2, I'm going to do chmod, right? Oh, if I can type, there we go, chmod, and then I'm going to do A, right? Isn't that what it says? And then I'm going to do a minus, because I'm going to take the permission away, if I can type, A minus read write for hello2. 2. There we go. And so now when I do an ls tac l, you will see that those permissions are now gone. If I want to add those permissions, I'm going to run basically the same thing, only this time instead of using a minus, I'm going to use a plus, and I'm just going to change it to read. So now if I do an ls minus l, you see I have read permissions on everything. So that's how I would do changing permissions from this aspect. Well, you can use octals too. And octals make it a lot easier for me to be able to remember how to do this, because if I want to change permissions, now, I say it's a lot easier, but if you think about it from the standpoint of having to memorize what each one of those are and do the math on it, it's very difficult. But if you've done it enough times, then you have it memorized, so it really doesn't matter. So for me, it's easier to say, hey, I want to change this to something that I need. So if you look in here, the Linux file permissions can be represented by numbers or octal values. So in this case, we're using 741, right? So the first digit is for the owner permission, so it's not changing anything that we talked about. The first one is the owner permissions, and in this case, we used a 7. So if we use a 4, a 2, and a 1 for those representation numbers, the 4, the 2, the 1, you add that up together, that gives you 7. So if I add those to 7, I get read, write, and execute. Okay, that makes sense. I think I can work with that. So if I want to change those permissions, well, that's changing ownership. I'm going to go and change those permissions to chmod, right? And in this case, I'm going to use 741, and then I'll take the file hello.txt, or hello2, because that's the one I was using it on. Now when I do an ls minus l, I actually see that I changed those permissions for the owner group, right, to do read, write, and execute. I got a couple of other ones here, and the last one that I've got is to change ownership, because as you saw when we looked in the Etsy directory, those files were owned by the root account because that's how they were created. So sometimes somebody will create an account, or the permissions don't exist properly on a file that you want to execute, so you're going to actually have to go in there and change those permissions. So in this case, I have to own it first. So if I want to own the file, I'm going to use a change ownership, or chown. So if I want to chown that file, I'm going to have to go and change the ownership to whoever I want it to be. So just for an example, as we're finishing this up, let's say hello2, I wanted to give root permission, so chown, and then this case is going to be root, who I'm going to give them to, and it's going to be hello2.txt. Oh, I can't do it. Why is that? There we go, sudo. So this is an interesting dilemma. I can type the whole thing out, or I can just use the double bang, which will actually allow me to run the previous command with the sudo permissions. Oh, that's kind of slick. Now if I hit ls tac l, it will actually show me that that file hello2 now belongs to the root account. So now you guys have any questions? Because this is kind of the end of the lesson. We showed you what Linux was, what Linux does, different flavors of Linux that we could utilize. We showed you how to do the installer. We gave you a little bit of the background and the history, and then we ran through some commands. Again, I recommend downloading it for yourself, being able to utilize it, installing it on your own box as your own lab, and then being able to play with these commands. Thank you.